Hello everyone, in this simulation we're going to see the field of a long coil. The long coil is made of 6 loops of wire, which have been threaded through a piece of paper. The main diagram shows an overhead view of the coil and a cross-section of the 6 turns of the wire. Let's drag the current slider 1 notch to the left to send the current through the coil. Note the dots and the crosses in the cross-section of the loops of wire, indicating the current direction of the coil. Now let's select field lines to display the lines of the magnetic force caused by the current in the coil. The lines of force pass through the current from right to the left. We go out of the left-hand end and around the outside of the coil to enter the right-hand end. What else has a magnetic field of this shape? Exactly, a bar magnet. If this pattern was produced by a bar magnet, where would the north end of it be? Yes, you are correct, at the left-hand end of the picture, because lines of force leave the North Pole and enter the South Pole. The N and S rule can be used to establish the poles of a coil. Look at this small diagram of a coil. If we look at the right-hand end of the coil, we can see that the current is traveling in a clockwise direction. If you draw the letter S, the ends of the letter also moves in a clockwise direction. At the other end of the current, the ends of the letter N moves in an anti-clockwise direction. Where is the magnetic field the strongest? Exactly, inside the coil. And how could you make the magnetic field stronger? Yes, by increasing the current. So let's drag the current slider 1 notch to the left. How would you know the magnetic field is stronger now? Well, the lines of the force are closer to each other.